Hello everyone, and today I'm going to be going over my homemade washing machine generator here. It's got a bit of an upgrade. I've attached this full bridge rectifier unit here, which is this one on the side, and a bunch of capacitors in here. And I also managed to find a 10,000 microfarad capacitor rated at 100 volts. And I imagine that I'm not going to be turning it enough to charge it over 100 volts. So hopefully it should be safe so long as I don't turn it for ages and ages. And then it's just wired up to two of the three output leads from this washing machine stator here, which I ripped out of the back of an old Fisher & Paykel washing machine. You can go to the trouble of rewiring the whole thing to get like different voltages and higher amperage or whatever, depending on what use it's for, like if you're charging 12 volt batteries or something like that to power your house or something else like that. But I've just left all the wiring the same and just taken outputs from what used to be the inputs. So basically how it works is we've got this big stator here, ton of coils around it with these little pancake type iron cores here. We've got lots of different little layers of steel that have been sandwiched together, which I believe is to sort of negate Lenz's law a little bit and increase the efficiency of the generator, or the motor. It was meant to be a motor, but it's a generator now. Then we have this massive wheel of magnets here. Finding the washing machine stator itself just on its own at junk shops and stuff is usually a lot easier than finding the magnet disc. But I did manage to find one that came with a magnet disc as well. I think I got the whole washing machine and pulled it to bits, and that's why I've got both parts. But as you can see, we've just got a bunch of rare earth ceramic magnets going all the way around here. And then when the magnets pass over the coils, obviously it induces a current and we get power. So to use it, you just plop this big old thing on here, and over here we've got so these wires here go into the AC inputs of a full bridge rectifier, which is hidden somewhere in here. I can't remember exactly where it is. I think it's over here somewhere. And then the DC output goes through these four capacitors, which are all rated at 450 volts, and a decent amount of storage here, but not, as much as you can get. And then we've got this massive, huge 10,000 microfarad 100 volt capacitor. And then this is just our DC output here. As you can see, there's nothing right now, but if we turn it, we do have to turn it quite a bit now because the 10,000 microfarad capacitor takes quite a while to charge up. So I'm just going to give this a few spins. So basically what happens is the stator just sort of sits on the ground here, and the carpet sort of holds it in place right now, and then this wheel just sort of spins. It's very loud and creaky, but after you've gone ahead and charged it up, we should get a bit of a spark coming off of here. As you can see, we've got a decent little arc there. I'll just give it one more charge. As you can see, we should get a decent spark. Oh, we're not getting anything. I think the wires must have shorted or something over there for some reason. It's not giving an output. Oh, just got to make sure that all the switches are turned on. That should be enough turns, I think. Nope, it's not wanting to do it. Anyway, it does work most of the time. I don't know what's wrong with it there. I think maybe the terminals. Here we go. Here's the problem. One of the wires has come loose off of the little terminal here, so I'll give it one last spin, and then I'll probably wrap the video up there. There we go, and we get a decent arc there. Hopefully the camera picked that up. A nice old, pretty intense arc. You can see that it's really quite a hot spark because the wire has melted. The wire has all sort of melted. There's like globules of coppery looking stuff on the end there where the arc was. Maybe I'll just do one more spark. it is quite fun. Here we go, and that is a decent spark. Obviously, if you have a lot smaller capacitor, or if this big capacitor wasn't connected, then it's going to be able to charge up to a much higher voltage, and you'll get a lot louder of a spark. And it can actually really hurt your ears if you charge it up quite high voltage. But anyway, yeah, that's my homemade washing machine generator. Thanks for watching, and have a nice day. Goodbye.